Hi, friends. I'm your host, Bill Murphy. Welcome to Tech Talks. This is our webinar series where we started this 2 years ago, and we invite professionals from throughout our industry to introduce you to innovative solutions in stormwater, erosion control, and sediment control, and so much more. And this is our way of keeping you up to date with best management practices, help you be better stewards of your resources, both financial and natural. And ASP, Bowman, Quick Supply, Cascade, we're considered trusted leaders in the civil and construction industry, and that's why you all are here. And we're considered that because we only work with the best people and the best products, and we only work with solutions that we would trust ourselves. And I feel like all of that is a great segue to introduce you to our guest, and I'll do that here after I go through my slides. But his name's Steve Lovering. He's my friend, my pal, and we've been working together here for some time, but we've even got to work together personally. Yep, about us, I already said ASP Enterprises, Quick Supply Company. I have that logo on today. Bowman Construction Supply, Cascade Geosynthetics. I'm blessed to work with all of them. I am our civil engineer, that number one there on the bottom of the screen. Doesn't mean I'm number one, it means we have one engineer on staff, but we do have many experts in all of our markets who often don't need my help on a day-to-day basis with so many of the products that we carry. My job is the technical assistance for our technical sales professionals and to help engineers and landscape architects through the design process, cities, counties, states, and federal government through review process and through their own design process, and even help contractors. We can do pre-bid help with our contractors with new solutions and pre-construction meetings for sure. There we are located across a large portion of the United States, and all the areas that are gray that aren't red, we have friends in every single one of those states that do what we do. So if you are in one of these states, but you have a project outside of these states, you can still contact me or any of us, and we can help you. We give free advice every day, no matter where you are or where your project is. And like I mentioned, we carry an amazing array of products, and we're experts at all of those. And if we need help, we ask internally. And if we need help beyond that, we ask all of our experts who are manufacturers, sales reps, and other people in our profession, in your profession. We're here to help, and we're very good at it. Logistics is our game. We have large warehouses, large yards, a lot of trucks, and a really dedicated team. I'm proud of the longevity of a lot of the employees in our companies and how proud they are to represent our company. So we wear logos, and I don't know, we're happy to see each other. We're getting back to business. You know, we were essential, so we stayed busy over the last 2 years, but we're seeing a lot more people in person, and I feel a positive energy happening. So today's presenter is perfect for that because he just exudes positivity. But you'll see our trucks out and about, and one of the things you'll notice is we can receive semi-loads of one product, and we can store that where we need to, and we can break down your order to be exactly what you need, when you need it, where you need it. That's huge, especially with the types of projects we're going to talk about today. Urban infill development, there's not a lot of space for staging and storing a product. We can do that for you. We can bring the contractor what they need when they need it. Yeah, my guest, Steve Lovering. How would you introduce yourself?
Thank you, Bill. Firstly, before I introduce myself, I have to say that we do work with distributors across the whole of North America with these systems. And I've had the pleasure of working with Bill and his team over the last 2 months. And these guys are the pros. He's not kidding when he says that they get product out timely, they've got it in stock, they know what they're talking about. It's a breath of fresh air working with these guys. So you're very lucky that you've got these in your towns and cities and are able to have them service you. It's fantastic.
Thank you.
With regards to myself, yeah, I was working as a landscape architect for a few years in Calgary, Alberta. I've got a really big interest in the urban realm, spatial design, etc., as well as obviously trees and other things. So this position at Citygreen, which I've been in for close to 5 years now, was a really good fit for me. We're able to help cities that are really struggling with their tree growth to cities that are really doing very well and everything in between. So we're basically bringing a lot of them from no knowledge with this information to suddenly having a what do you call it over there, I guess, a minimum soil volume requirement, which means every tree that gets planted does really well, thrives over not 3 to 5 years, but more like 50 to 70. So without further ado, I think maybe we should get into the presentation here, and will hopefully give you guys some really good information to take back to your towns and cities. Or if you are municipalities on this call, reach out. We'd love to do presentations for you. Landscape architects would love to do presentations for you. Engineers, same thing. We're here as a resource for you going forward. So.
Thank you for saying that, Steve. That is part of what we like to offer with the PDH certificate as well, with that contact information. Is a lot of these folks who are on here are their only person in their office that's on, and they're going to have light bulb moments and want the rest of their office to hear it. Rather than send them a link to the YouTube video, I would love to just do a lunch and learn. So thanks for mentioning that.
You bet, absolutely. Yeah, so we're going to spend, I don't know, maybe 30 minutes, guys, just going over some really cool new technologies in the green infrastructure industry. I think anybody out there that's involved with trees or stormwater management is going to find this very interesting. So we'll start off again. My name is Steve Lovering. I am with Citygreen Urban Landscape Solutions. And before we get into the really cool stuff with the soil cells and how we're running stormwater through them, etc., I want to just point quickly to our website and some of the other products that you have access to through Bill Murphy and his team. This is the first page of our website here, and as you can see, we've got some different titles up here. We've got urban tree planting, we've got stormwater management, we've got living walls. We do deal with a lot of green infrastructure products. One of the products that we like, which is really catching on, is our tree grates. Now, in the past, there's been nothing really that cool about tree grates. You know, they're made of ductile iron, they sit in the ground, they look okay. We've actually turned the concept completely on its head now. And we manufacture these things out of stainless steel, which you can see on the left here. So this tree grate is lighter, it looks nicer. We have these growth rings that are inbuilt into the tree grate so that when the trees start to grow in these urban environments, we can actually cut these growth rings out, which makes obviously more room for the tree's trunk. We also have watering tubes in there as well, incorporated into the tree grates, and we also have smart technology that's built into them as well, which I'm going to go into that in a second. This is a really cool product as well. This is our Invisigrate. Invisigrate, invisible, that's how we came up with the name. It's not that creative, but it works. Basically, this is for any projects where any designers have got really cool pavers and nice looking pavers. They don't want to see the tree grates, they want to have the pavers carry on through the whole design. And this is where this fits in really nicely. Typically, to custom make these things is very expensive, but we can do these for anywhere between $2,000 to $3,000 for the tree grates and the H20 loading, etc. as well. Now, curb inlets. Again, I mentioned stormwater management, bringing water from the roads underneath a sidewalk into a mass of soil. This is a really good way of doing this. We actually had to come up with this product because nobody else had, and we'd waited at that point 3 years. So we came up and developed this product. It works really, really well in a lot of states across the US. And again, we can use this just to take water into areas of high planting. We can use it to take water into areas of storage. There's lots and lots of different uses for it. And this here coming up is a side and a top profile of how it works. Again, if we need to be collecting any silts and sediments, we can do that back here. And we certainly have a real wealth of knowledge when it comes to that as well. So if you want to discuss that any further, please reach out to us. Now, this is really getting people talking at the moment as well. This is our sensor technology. And again, we tried to use products that were off the shelf and that were, again, very expensive, $5,000 to $10,000 typically for these types of sensors. But we scrapped that and we came up with our own. And by doing that, we're actually able to use these things for salt, moisture, and pH in the soil. So we can detect if something's going sideways with these soils really quickly and early on in the process so we can get in and fix anything. This is how these sensors look. The one on the left there, this is our Citygreen sensor. Again, it goes underneath a tree grate and it can predict all of those salt, moisture, pH issues that might be coming up. As well as we also have our dendrometer. And this thing here measures the growth of the tree's roots. We don't have to wait 3 to 5 years anymore to see if these soil cells are working. Instead, all we have to do is incorporate one of these dendrometers into the tree planting, and we can find out within 2 to 3 months. So this is really, really good information for any cities, municipalities that want to incorporate some of these things into their streetscapes and really want instant information on it. This is another advantage of these sensors too. We have cities across the United States that are actually planting their trees based on the information they're getting from these sensors. So instead of thinking, hey, we're going to water all the trees on Brown Street the second week of every month, and we'll do Green Street the third week, etc., etc. We can now send these crews to water these trees, and only water the ones that actually need the moisture, not the ones that have already got lots of moisture. So again, this is a game changer in cities' ways of watering the street trees. Now let's get into the cool stuff now, guys, and this is really where we sort of start talking about the different uses of the soil cell products, which we're about to tell you about. These urban environmental challenges are vast and large, and we're very proud that we're able to help the cities with these different challenges. The first one I'd say is the trees in community spaces. So this is where the soil cell technology came up. Everybody likes trees in hardscaped areas. Everybody wants to be walking around streetscapes with lots and lots of tree canopy. It provides shade and everything else. But the two problems we have is the picture on the right there is the first issue. Either we've got lots of soil volume down there, but the trees are actually using it and breaking up the sidewalks, or we're planting trees into 4 foot by 4 foot squares in the ground. They've got no soil volume and they're dying after 3 years. So they're the two issues we have. Again, we're going to be talking more about this, so we'll move on to the next one. Clean waterways. We're currently sending all of our polluted stormwater from our streets. It's full of oil, petroleum and metal pollutants into cities' pipes and infrastructure underground, which is again causing all sorts of issues. Silt, sediment, there's lots and lots of problems with this. So again, we're really turning this problem on its head and helping to provide a solution. Urban heat island effect, you guys definitely deal with this in the Midwest. This is obviously a big problem, and with our system we can provide lots of shade to these streetscapes so that they are nice places to walk around, nice places to shop. And also meeting urban canopy targets. So a lot of cities across the Midwest have got urban canopy targets they're trying to meet. We show a parking lot down here. This is probably the number one way of turning these spaces from grey to green, which you've probably heard that concept quite a few times. So we're turning these grey parking spaces into beautiful canopy, trees everywhere, just really nice places to park your car, and you can get out and get back in without frying. So very nice. Now this is the product we're going to be discussing today. This is the Stratavault 30 series, and the main purpose of this product is to provide the structural stability to whatever's above it. So typically we have sidewalks above this, but we also do roads. We can also have parking lanes. There's many things. So these things are providing the structural stability while having a void space within them for soil for tree roots or soil for stormwater management. Or actually, in a lot of cases, engineers are actually specifying these systems to compartmentalize and organize all of the pipes and infrastructure underneath the ground. So there's multiple reasons to use these systems now. And of course, as mentioned earlier, these tree roots, they're getting really big. And we can no longer be planting these things into a 4 foot by 4 foot square because the root system just work their way around the root ball, they strangle the root ball and the tree dies. So now these tree roots have got all of this room to use underneath the sidewalk. And just a heads up, these tree roots will be going all the way between each other here, all the way down the sidewalk. And then these trees can be these huge, massive street trees that we're all designing. So if we look at that a little bit deeper, we can see that these tree root systems, they do need a lot of room if we are requiring these trees to be of a good size. This is very typical of how much room these trees need to really thrive and become these large street trees that we design in for aesthetics, health benefits, and also for shade as well. If we don't have the room underneath the ground, then we're not going to get the room above the ground either. It's just as simple as that. The tree canopy is going to be typically as large as the root system below the ground. Now that does change depending on the species, but that's a very good rule to go by. So let's look at an installation. We've got here on the left, these trees have all died. We can see these in every city. If you go and walk around the city that you're from this afternoon, this evening, you'll see there will be dead trees in a lot of different spaces. It's sad, it's unfortunate. We used to create sidewalks and roads on top of compacted soils. Now that was fantastic for one reason, is that the compacted soils gave the tree roots lots of nutrients and room to grow. And if you look at trees that were planted more than 30 years ago, you'll see these huge, massive elm trees, all sorts of different species that line in the streets. Construction methods have completely changed now. We don't have compacted topsoil anymore. We use granular materials, concrete, asphalt, etc. And there's just no room for the trees. So what we're doing here is we're providing that room again for the trees. We're providing the soil volume so these trees can thrive. So if we look at this example here, we excavated this pit out. We've got 4 inches of granular down here, and then we start installing the soil cells into this pit. On the left hand side, you'll see here are the bases. The modules just very simply fit into the bases. The image on the right is of 1 layer high, and the square in the middle is where the trees are going. Image on the left, this is 2 layers high now, and the geotextile membrane down the side is stopping the soil from getting out, and it's stopping the granular on the outside from getting in. So if you look at the picture on the right now, we've actually started to install the soil via a slinger, and now the image on the left is the top grates have been installed. That's all full of soil now. We're going to plant that tree into that space, and it's going to have all of that room now for that root system to really grow and thrive. The image on the right, we've folded that geotextile membrane over now. We've overlapped it in the middle by about 12 inches. And once we've done that, we can then add the granular material onto the top, again 4 inches, and compact that, and then we pour the concrete. So just to go into that a little further, guys, the concept, especially when we come to tree growth, we're not planting these trees into 4 foot by 4 foot squares anymore and crossing our fingers and hoping to grow. Now we are giving these tree roots all of this access underneath the sidewalk to use for their growth. And we are seeing some of these trees really thriving.
Steve, can I jump in with you and ask a question?
Yeah.
For those who are paying attention here, what do you think would happen if we didn't have the soil cells in here? The city engineer is going to require you to have compaction under the streets and also compaction under the sidewalks. You see that plate compactor in that picture on the left by the construction worker. If we didn't have those soil cells in there, that compaction is going to take itself all the way down through the soil that was under there, if there were no cells, just soil, down to that compacted rock base on the bottom. So this whole thing would be so strongly compacted that if somebody came and excavated a hole just to put a tree in there with a root ball, the roots would never have a chance of going beyond the size of the root ball the day it showed up. There's just no way they would be able to make it. If they did make it into that compacted soil around them, they would have to heave and lift whatever's around them, like that previous picture you had that showed that devastated public sidewalk. And we've all seen that too, where the tree roots have to come close to the surface to get water. If they're not able to get water down below the surface, they have to try to get to the water. And normally the water in something like this would just set up near that granular material. However, now with the system you have, the soil cells take all of that compacted load. So the soil within the cells is not getting compacted by that plate compactor. It's already been walked in by foot, and the way that these Stratavault units are capped off and then covered with the geogrid and geotextile, that protects that load underneath. So that whatever the walked-in compaction is inside those soil cells, that's what it's still going to be even after they run the compactor over top of this granular material. That compactor is just to give a good base to the sidewalk. That's why you show those curb inlet openings to get water down into those soil cells. That's why you encourage design of these systems to let water get down into those cells, because they're not going to make their way through the sidewalk. They're not going to make their way through that compacted rock. You're going to get a little bit of water in those tree grates, but those trees are going to need more water than that. So you're going to either have to bring it in through those curb inlet openings or connect it to your storm sewer system, which Steve will talk about, or add water with those moisture sensors so you can see which ones are not already getting enough water without a little bit of help from mankind. Thanks, Steve, for letting me jump in there.
That's awesome, Bill. And are we on, just so I know we're on the right slide here, are we on the slide right now that shows the tree and the concrete sidewalk?
Yes.
Are we
Yep.
good? Okay, fantastic. Thanks, Bill. Yeah, please jump in and confirm it, back any of that stuff up. That's great. Okay, so now let's jump onto something very closely related but a little different. This is stormwater management, and this is really a game changer in our urban areas, in our downtown areas. We're taking rainfall that falls on the roads and the sidewalks, and instead of sending that water into our city systems, where it's causing all sorts of problems with aging pipes, aging infrastructure, silt and sediment buildup, too much pressure, we're talking about actually sending that water into our soil cell systems underneath the sidewalk. This is a really good example here. So if you can see this, this is a sidewalk, this is a road. Typically the catch basin is either in the middle of the road or against the curb, depending on again where you live. And again, instead of sending the water into the city storm system down here, we're saying, hey, why don't we send this water through pipes into the soil cell areas? Two benefits of this. Firstly, the trees and the soil will clean the pollutants out of the water. And secondly, the water will feed the trees and the pollutants, believe it or not, as well. The trees will take those up for its growth and get rid of what it doesn't need out of its leaves. So this is really a bit special. It's a totally natural way of doing it. If we're talking about stormwater management from a cost perspective, it's almost free. I mean, we're spending the money for the tree health, and then you can use the stormwater management as an added benefit, or vice versa. You can use these things for the stormwater management and get the tree growth as an added benefit. So this is really cool, and it's next level, guys. This is not been done too many times before. I'm not going to talk too much about this slide here, but this is our silt and sediment catchment product. There's a few out there on the market. This is what we use to catch the silt and sediment before the water goes into the pipe, which then feeds into the soil cells. So again, we won't talk too much about this today. But if we look at, this is a plan view of how it all works, we can quickly describe the process to you. So this is a tree over here. This, by the way, is a sidewalk. It's a plan view of a sidewalk. These are all the soil cells. Here's another tree, and this is a perforated pipe network that leads from the catch basin. So water comes into the catch basin, runs through this pipe into this network of perforated pipes, runs through the system, makes the soil nice and moist, and then the trees suck that moisture up and use it for its growth. Now let's look at some different ways that we can bring this rainfall, professionally known as stormwater, in from these roads and sidewalks. So there's four main ways that we're doing this right now. The first way is the catch basin, which we've just described that process to you. The next way would be using curb drains, curb inlets, which I showed you earlier. That's one of our products. We can quite easily pour that into the curb at the time of the concrete pour, obviously. And again, that curb inlet is then linked to a network of perforated pipes. Okay, so that's the second way we'd do it. The third way is by using permeable solutions, so permeable pavers, permeable grouts. That water can then just drain straight through from the surface into the soil underneath. And again, those tree roots can just take that up now and use it for its growth. And then we also use trench drains as well, which of course these are used commonplace now. Maybe the difference here that we do connect these trench drains to this perforated pipe, which again goes in a network or a figure of eight throughout
Yeah,
the country.
we could include those systems with the Stratavault soil cell system. We could package the whole thing together with all the fabrics and everything. So I love it.
Yeah, absolutely. You can get all of these products that relate to the soil cells from these guys. So yeah, they've got the whole kit and caboodle. Now, another interesting thing as well, we can actually use these products as stormwater tanks underneath the ground as well. There are, again, other products out there in the market that can do this, but our product is unique in that it's the only system in the world that can be used for both tree growth and for pure storage. So we can even do a combination of both of those on some projects, which again, that is a fascinating conversation. Some of the things that we can do in the urban realm. Now let's just look at a couple of applications of where we can do this. Streetscape applications is obviously a big one. This is our bread and butter from day one, and then we can also do parking lots as well. Here's a parking lot application here. In this particular application, we've got a similar to a trench drain running down the centre. All of the water then runs from the surface into the trench drain. The trench drain then has a network of pipes underneath it, and underneath this parking lot, well, I shouldn't say underneath the whole parking lot, it's underneath the lanes, here the parking stalls, we have our Stratavault product. So that's full of soil, and these tree roots are using all of that soil for the growth. So the trees are very happy in this instance, and they're really thriving. Now there are other applications like light rail transit projects. These ones are the big guys. We specialize in doing these monster light rail transit projects now across the country. I think we're involved in about 6 of these at the moment. The multi-million-dollar projects as far as the soil cells go, and obviously some of them are billion-dollar projects as far as the project cost. And typically, just so if you want a number on this, the soil cells equate to less than 1% of the construction costs. So they're not that of an expensive option here, especially for what we're getting out of stormwater management and urban tree growth. We also use these products as well to stop flooding. So if any of you live in regions where you do tend to find a lot of flooding, we can bring the water into these massive soil cells underneath the ground via, again, trench drains in this example, but we can do all sorts of different applications there. And then this is probably the coolest project that I've ever been a part of. So much so that I can't even get it out my mouth. But this one is really exciting, and this is talking about working with developers and cities, municipalities. So this client on this project here owned around 20 different sites, 20 different development parcels, and this parcel on the left, just to give you an example, is an average size development parcel in North America. So as per every development parcel in North America, depending on where you live, they do need some way to collect the stormwater from the site, and this one wanted to use a stormwater pond. So we were chatting with the engineer on this project, and we said, hey, you want to sell 20 of these development parcels in 20 years. We can help you make these development parcels so much more valuable in even 5 years, and we'll show you how. So we talked to them, and the idea that we came up with was actually to remove the stormwater pond completely, and that would give us more development opportunity there for parking, for buildings, for green space, for bike lanes, for green space, parks, whatever that may be. So they said, all right, this is interesting. So we carried on the conversation, and we dug a little bit deeper into it. And when we did, you can see that the areas in blue are where the soil cells would be, and the circles are the catch basins where we bring the water in. So once we bring the water in and we use the soil cells for stormwater capture instead of the stormwater pond, we found that actually we could capture more water. But not only that, obviously because we are using the rest of that land, that when we dug a little bit deeper into this and we actually put some financials behind it, we found that the piece of land on the left with the stormwater pond was worth about $14 million. Again, in 5 years, because 20 years was too far ahead. Whereas when we actually use the soil cell product on the image on the right, that piece of land is now worth $24 million. So that piece of property went up $10 million because now we can use the whole of it instead of just a portion, because we needed the stormwater pond to collect all the rainfall. So this was really, really exciting, and obviously this developer got very excited about it. The city got very excited. Everybody's fully behind it, and now this has caught on, and we're doing many, many projects. Some of them in, we're talking about projects in Las Vegas now. They need their water. It's very important for them. They also need big tree growth for shade as well. So we did 2 projects in Vegas last year alone, and we're hoping to get a few more this year. Also, Disney are a big customers of ours. They've been buying our product for about 10 years now. Again, this works really, really well for them. They need big trees, and they can't have the damage to the sidewalks, to the plazas, because they don't close the pipes for anything, aside from COVID-19, obviously. But and then on top of that as well, there was we do lots of projects in cold places as well. So that's another the few of the Disney projects we've done. If there's any of you living in cold climates, I'm sure you all know about Winnipeg. We do projects right across Alberta, Winnipeg, Ontario, in Canada. Our product does not get damaged by the cold weather, which is really nice. And actually, some of the best projects we've ever done are in cold climates. We've also done projects in places like Denver where we get a lot of Chinooks, hot and cold, hot and cold, hot and cold. So yeah, there isn't a weather pattern that we can't deal with and work with, and we can pretty much guarantee that the trees will thrive in all of these conditions. Now, when we look at the product itself, this is how we measure the strength. We put it into a large device and we basically crush them until they bend or explode. And then we take these measurements from them, which, of course, where we are is PSI, pounds per square inch. Our product is 51 pounds per square inch. And our nearest competitor is about 25 pounds per square inch. So we're twice as strong as anybody else on the market. Bit of a technical issue here. Not sure why the screen's not. Oh, there we go.
There's a little bit of a delay on some of them.
Yeah, get that fixed, Bill, for the next one. So
I'll just screw up on the roof of the house. I got to turn the antenna. It's kind of windy outside.
When we're looking at working with pipes and utilities, you might have had some pushback from cities or engineering staff or other departments within the city when it comes to planting trees because of pipes and utilities and underground infrastructure. We've worked through this problem. This was definitely the biggest pushback that we got in the first 2 or 3 years of business, but now we've come up with such a slick solution to this. Please reach out, guys, if you've got any questions at all on this. We do projects now in downtown London, cities all over Europe, which have got like literally hundreds of years of infrastructure, and we're still able to work around it, tie all of the pipes and utilities off with root barriers and things, and make a really big success of these projects. So don't let that be a concern. And then when we look at environmentally strong solutions, we're actually manufacturing our product out of 100% recycled plastic. Spoiler alert, in the next three months, we're going to be actually manufacturing our product out of plastic from the Oregon, Washington, and British Columbia coastline, which is going to be a bit special. So more news to come on that shortly, but that's going to be very exciting. We can also provide lead credits for you as well. So design services, if you've got any projects where you're looking at maybe incorporating some of these soil cells in, we can do all that for you. Just send us the landscape plans and we'll put the soil cells in, show you how much volume they can take from both water storage and tree growth. And also we can take it a step further as well and show you exact layouts, show you exactly how many modules, give you some pricing, etc., etc. And to help with it also, we have an urban greening grant program. This is really, really exciting. So we'll actually help you with the cost of the soil cell product, and we'll turn your project into a nice pilot project or case study where we can do a bunch of different comparisons between tree growth, stormwater management, trees planted in structural soils, trees planted the regular way they have been for the last 30 years. Lots of cool stuff we can do with this, and we'll video and take pictures of the whole process and give you back a 5 minute, really nice program that you can sell in your marketing for your company or for your city. Reach out about this, guys. It's really, really exciting. We do about 6 a year. Well, we limit at 6 a year. So if you want to get involved in that as well, let us know as soon as you can. I think we've got a couple left for 2022. And I think that might be almost the end of the presentation. This is some of our industry partners we work with across the US. Again, I think we've worked in most states now. Certainly the Midwest is a really key area of ours. We love it. And that finishes the presentation. Obviously, over to you, Bill, for questions or anything else.
So I want to take over controls here, just because that's how I am. And I'm going to do that on purpose because I am going to check the Q&A. We had a couple people ask questions during, and in order. One of them was talking about using geocells for tree root protection in modern granule approach. So JP George, JP, if you want to specify a little more detail on there, that would help me. I'm not sure, Steve, if you understand that question, using geocells for tree root protection in modern granule approach. I think maybe his question is, what are we infilling the soil cells with, and how do we protect the tree roots from that other material? I think it goes back, and I don't know that we can click back to it quickly, is the combi grid, for lack of a better term. And you want to explain that a little bit?
Yeah, absolutely. Yeah. So basically what we're doing with these soil cells, again, the soil cells, all they're doing is producing the structural stability for the sidewalk above. It's the media that we put within the soil cells that makes all the difference in the world. So when we've got a nice soil media, that's what's going to keep those trees happy and thriving. And basically what we're doing, for want of a better word, is we're trapping those tree roots within those soil cells, within that soil, so they can't wreck any infrastructure. They can't get up and damage sidewalks. But not that that's bad for the trees. They've got enough room down there where they can now grow and live for 50 to 70 years.
Yeah, and he chimed in again. Good job, Steve. You answered it. He said the question came in as we were talking construction and using the geocells to avoid compaction during access. And so he got his question answered. That is another point I'm glad he said was access. We talk with pre-bid and pre-construction, during construction with contractors. Some of these underground systems, you can't drive any equipment on them. You absolutely can't. And you got to put 12 to 24 inches of cover on them. You got to protect them before you drive equipment on them. Well, these things, you have tracked skid steers driving above Stratavault all the time. I mean, by the time you backfill these, you put in the sidewalk, they're going to drive trucks up on these sidewalks, whether you want them to or not, whether it's part of the plan or not. Somebody's going to be up on that sidewalk with vehicles. And these things are rated for what, Steve?
Yeah, they're good for H25 loading standards on their own. Our competitive products out there on the market, you have to put, like Bill's mentioned, 12 to 24 inches of product above them just to meet H20 loading standards. So the system is a lot stronger than the other guys out there.
Absolutely. And then another attendee said, has anyone considered the force and uplift of the mature tree on the sidewalk? And that's actually one of the reasons this product was designed, correct? Talking about freeze thaw, and I think you already answered that. You've got Stratavault in the ground in some very, very cold places that have very, very vastly differing climates, from super hot and dry to wet to really cold.
That's right, exactly. Yeah, we don't see any issues there as far as uplift on the sidewalks from the tree roots. That's one of the reasons it's very, very beneficial. And you can imagine we've got typically 32-inch depth of soil cells here. So these tree roots would have to get like really, really massive to ever cause that sort of issue there underneath. We've got projects that are 15 years old where we've got absolutely full mature trees. We've gone in there after and had a look what's going on, and everything's working really, really well down there. So yeah, that's not something we're worried about.
And I will answer the second part of his question because I have a lot of personal experience with this. He's asking if could wind on a mature tree pull up the roots in the sidewalk. Lee, let me tell you something. In my personal time, in the last 17, 18 years, I've dedicated most of my vacation time to mission trips where I help all across the United States, usually after natural disasters. Hurricane Katrina, Rita, tornadoes in Greensburg, Kansas, Joplin, Missouri, Tuscaloosa, Alabama. derecho in Iowa at Cedar Rapids. I've been doing flood protection and flood rebuilding, not flood protection, flood recovery, flood rebuilding in Cedar Rapids, Iowa, Slidell, Louisiana, number of places across the Midwest. And at some point, Lee and I could play the game of end of the world, Armageddon, and there's not a darn thing we can do about it. So yes, a terrible wind could uproot a tree, no matter how well you protect it or how mature it is. I've seen it. I've also seen structures that have been around for over 100 years and withstood 100 years of terrible weather events. But one day, one winter, one spring, one summer, it can experience a storm like it's never seen before, and it can pull down that structure. So at some point, we could do that ultimate. There's nothing you can do about it. Well, you rebuild it. And the good news here with these modular systems is whether it's a natural disaster or somebody else does something physically to damage a site, you can rebuild just the part that needs rebuilt. The modular system's still going to do the job throughout the rest of the area.
And also, Bill, I will mention as well, there is a product that both me and you supply as well, which is called the Platypus tree anchor.
Yes, thank you.
Which is a really good way of getting that tree really solid in there at the early age. Once those tree roots start growing and really getting into that soil, that's a good anchor. But before that happens, we've got an inexpensive, really good option. That's a tree anchor that you can totally use as well.
Well, and another guy that he attends almost all of these that we do is Don, and Don asks some good questions. Don, I'm going to try to fly back to a slide that you need to see, and Steve can talk through it. He's asking, what do you do if you have utilities that are parallel to your system as you're building it? And he probably asked this early on, and you got to it. This is the only system like it that can have some of these members be cut. That bottom center picture shows there's not a connector piece in between those two vertical columns. Because there's a conflict, and the rest of the system can be built as designed, and it's still fine. It's still structurally strong, and it holds together. So these systems are adaptable to whatever you run into in the ground. I cannot imagine what London's like. I've been in downtown Des Moines, St. Louis, Omaha, Kansas City, Denver, where we had a map. The surveyors marked out every utility known to man. And when they started to excavate, there were all those utilities that weren't known to man. There were all those things that were not in the same place the drawing showed. And that stuff happens more than most of you folks would even believe. You run into conflicts. It's not if you're going to run into conflicts, it's when and where we run into conflicts and how do you handle it. So Steve, how do you address that with all these projects you've had with existing utilities?
That is a great question, and that's, again, we try. This is our 6th generation of soil cells. So we've had 5 before this, and we really tried to adapt the Stratavault so that it could be ultimately flexible. Now, if you look at this picture down there, sorry, I'm not. If you look at the bottom picture there, thanks, Bill. You will see that there's a module there. Yes, that beam has been cut out of there, and that doesn't void our warranty. It's still strong because, as you can see, the module itself is actually linked to the rest of the modules as well, so it's all still stable and good. Now, if we wanted to, let's put that beam back in there. Let's forget the fact that that's cut. We could then remove those bridge connectors, which you can see just north of there, Bill. That one, you can remove that, and you can actually butt the module up against the other one as well. So you can imagine lots of different ways of moving these modules around. If we have to, we can cut them as well. So the flexibility is really, 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 really important.
I'm going to look at the attendee list real quick because and I don't know that I can make him a speaker, but there's someone on here and who has some experience that I'm not going to get a chance to do it. So I'll just talk about it with different systems, and I won't name any other systems, but it's somebody who has experience installing different systems, and until we physically delivered one of these units to that person, and I won't say their name because I don't want everybody from the competitors or anybody else to try to go bother this person. I respect the privacy. Until they went hands-on, and you and I have seen this in person in a certain city here recently, Steve. We delivered these full-size units and let people grab them. We even had some people get up and stand on them in a conference room and get up and stand on and dance on this one versus others that are on the market. And they were absolutely blown away by the power and strength, yet lightweight, ease of use, ease of assembly of the Stratavault unit. Once people go hands-on with this unit, lights come on and they are ready. They're ready to rock and roll. So I encourage everybody on here to do what Steve said early on. Let us know when you're ready for us to stop by. When I say us, if Steve's in town, we'll bring him to you. He's wonderful in person. But if he's not, we are. So you could have somebody in your ASP, Quick Supply, Bowman, Cascade Market come to your office with the physical units so you and your friends can put them together and see how fast they assemble, stand on them and have fun. Send me a picture. I'll tell you what, I should do a contest. Send me a picture of you standing on a Stratavault unit during your lunch and learn, and I'll send you a prize. I don't know what it is yet. Don't know how big. Maybe it's a new car. Maybe it's just a gift card or a pair of gloves. I will send anybody here, if they send me a picture of them standing on a Stratavault unit in their conference room or on their job site, I'll send them something. That's how serious I am about seeing is believing. Once you put your hands on this product, you'll see how quick and easy it is. It's just really intuitive. Whether it be the little caps that go into the columns and protect those, or the plate that goes over the center of the grid that goes over the top that holds the material so it doesn't let the above material come down into the cells and compact the cells. When you finally wrap them and burrito wrap them and do the compaction on top for a sidewalk, these things are awesome. I love to go hands-on with everything we promote, everything we sell, everything we recommend, everything we use. And I've gone hands-on with this product, and I have 2 of these cells in my garage. They're going into my truck right after this webinar. I'm going to the Iowa APWA Spring Conference in West Des Moines, Iowa tomorrow morning at 7 o'clock, and I'm going to have one of these units there. So my Iowa friends that are on this webinar, come see me. Come see it'll be Quick Supply. We're Quick Supply in Iowa. Come see our booth. Steve Crable and I will be there, and I'll have this unit, and I'll let you stand on it. I'll have the grid there. You can stand right on top of it. Even you big boys, come on down. So, Steve, I did have a couple questions for you. I was going to ask you, why are those trees dying in urban areas? You and I visited one city in particular recently, and I don't want to name them by name on this webinar, and we saw a bunch of grates that were empty or they had dead tree stubs sticking up out of them, or we saw broken grates or grates that were kind of shifted out of the hole, or no grates at all. The one on the left is different. There's no grate there. That's the biggest tree we could find in that downtown, but it was destroying the sidewalk. But for the one on the right, why are those trees dying?
Yeah, it's a great question. What a lot of cities are guilty of is the snow removal guys, right after a snowstorm. Obviously, everybody's salting the sidewalks, right? So then the snow falls, and the snow removal guys will actually sweep the snow into the tree grills. Now, they think that's fine, and there's room, and no one's walking there anyway, and we'll pile them up against a tree, and no dramas. The problem with that is that a lot of that salt is also within that snow, and that salt then goes directly into the heart of the tree root, the root ball, and that kills the tree. Thousands of examples of that across the country. It's happening every winter, multiple times. If we can, that's one thing I will urge everybody on this call. We have to stop putting our snow into our tree grills. The moisture, yes, that might be nice for the tree, but the salt that comes along with it's giving it no chance. So that's number one. Number two is soil volume. We have to provide the soil volume so that the trees can live for about 3 years. Again, this tree on the left, that was planted. Guess what's underneath that sidewalk? It's a mass of compacted soil. We don't do that anymore. We don't put compacted soil underneath sidewalks. So literally that tree would have that, 3 foot by 3 foot space for its root system. That would be it. And that would have died a long time ago. So we either have to provide compacted topsoil or we have to do something else, which is why we use soil cells.
So when you talked about soil volume, you just led me to one of my questions is how much soil volume? You said this, but I don't know it. I didn't learn it in college, and I don't think a lot of people are learning it yet unless they're a landscape architect or unless they're an urban forester. Those people are experts, but they're probably screaming and people aren't listening, so we need to help get the word out. How much soil volume are we talking about? You mentioned it, but give me another idea.
So cities where they've been using these products for a while, the math is telling them that to have a really fantastic, successful project, we should be using about 1,000 cubic feet of soil per tree. Now, for cities that are developing this technology, that seems like a big number, and I completely understand that. So we should be really starting about the 500 cubic feet per tree. That's a good number. And this is all based on small, medium, large size trees. What species is that tree? So it's actually quite an involved question. But just to get started off, let's start talking about 500 cubic feet is a good number to at least start with. Right now, what's that there? That's going to be, right now we're using anywhere from 20 to 100 cubic feet per tree.
Yep.
It's not enough. Trees are dying after 3 years.
That makes sense. They say the same thing about putting a fish in a bowl, or you putting a little plant in the house into a little planter. If you want it to really grow, you got to replant that into a bigger pot. Take it outside. If you keep it in the small container, it's going to stay small, but if it wasn't designed to stay small, it's just going to die. So,
Exactly, Bill. A good example is a bonsai tree, right? They put those things into small little pots because they don't want them to grow very big, and you're going to get the same thing with an urban tree.
you talked about running the importance of running water. We already heard don't put salt in with the trees. What is the importance of putting street runoff, parking lot runoff, train, whatever runoff, rail runoff? What's the importance of running that through the soil cells?
We found over the last 14 years that our really successful projects have had a lot of water go into them. So whether we're putting some really good irrigation in there, or whether we're just sending the street runoff into these tree pits. And again, the design of that is really important too. We don't want to be putting a tree next to a catch basin and feeding that water straight into that tree's root ball, because again, that might be full of salts as well. So there's some really innovative ways of doing that, some really simple ways of doing that. Reach out to us, we can help you with that. It's a really, really simple concept. And why would we not be doing it as well? I mean, we've got catch basins in a curb, and then we've got, in that picture you've shown there on the left, we've got a tree's root ball right there. Why would we not be feeding that water into the area of that tree for its growth, instead of then redirecting that water into the city's pipes and then into a lake or an ocean where there's all these pollutants?
Yeah,
So
and I
there's a
think
really good, much clever ways of doing this.
one of the things I'm hearing cities talk about more and more over the last 8 years is slow the water down, cool it down, filter it, monitor or regulate those minor storm events that happen on a daily basis, and you're putting such a huge impact of better water into those streams. Granted, during a flood, it's going to bypass the trees, the soil's saturated, we get that. But most of the events that happen, they benefit from passing through some type of a biosystem that involves clean or involves soil, and the soil is going to clean that water. I mean, I live in the country. I have a septic system. For those of you city folks that don't know, a septic system is whatever we flush thrown down our toilets and comes down our sinks and showers, goes out into a holding tank, the solids settle, and then it goes out. All the liquids go into this lateral field that percolates into the ground. The ground filters the water before it gets to the river and goes to the next town's drinking water source. So that's what nature's been doing forever, and we're just trying to help that process. Because when we pave paradise and put up a parking lot, as the song says, we change that whole ecosystem. We change the way that water used to function on the globe, and we now have ways of doing this lower impact development green infrastructure, and one of them is directing runoff through these types of trees. If you're going to put runoff in there that comes from the streets and assault pollutants, you also want to have enough water going through it that you can flush that system too. That'll be less burden, less stress on the trees and the other plants, is make sure you're moving enough water through there to, well, they say the solution to pollution is dilution. So you want to dilute that stuff.
Exactly, and for the engineers on the call as well, we're actually able to get a 95% TSS removal rate by doing this, which by the way is completely unheard of in the urban realm. So we're cleaning water, we're growing trees, and we're helping cities with their infrastructure issues. It's exciting.
Now, better than these two pictures, other than you being in one of them, is that picture that shows the upheaved sidewalk and the bricks that are totally, I call them devastated. When I was a little kid in small town Iowa, rural Iowa, we got bored. I lived out in the country. When I would go to town and visit my city friends, one of my favorite things to do was take a BMX bicycle, go really fast, and find those and jump them. I had a little jump. I was the original parkour guy, but it's a hazard, and cities are always trying to mitigate risk. Rather than go out there and tear out this panel and use a shovel and chop down the top of the roots or kill the tree and just put another concrete panel in there, cities are finding they have an opportunity, rather than repeat the same thing they've done every 3 to 5 years of digging up these holes and putting in another little plant that or tree that won't survive. They have a great opportunity to redo all of them. And if they're going to be in there digging up a hole this big, they might as well excavate a hole this big and put in the soil cells and then have great success, and they give that tree a chance to live 50 to 75 years. It helps property value. You showed a parking lot that was massive, just a sea of pavement. A real estate broker would mention there's parking available, but they wouldn't stand back on the other side of the parking lot and show a quarter mile of pavement and then a little building in the distance. They would show the building. When artists do renderings, they show pretty trees. They show greenery. They don't show the little tiny ones with the tag still blowing in the wind that says it's a 1-inch caliber tree. They show what it's going to look like in the future. And most of those artists and landscape renderings are bogus unless they plan to have these really healthy trees live a long time, because they're drawing for the best case scenario. Thank you all for your time. I respect you. I value you. I appreciate you. And I hope to see you in person. Let us bring you lunch. And if Steve can't be there in person, we'll get him on there virtually.
I'll be there in person. We've definitely got a lot of work to do in these regions. So
You're a good friend, Steve. I appreciate you, buddy.
I appreciate you too, my friend, and thank you everyone for joining. It's this is great. This is fantastic.
Awesome. Take care, everybody. Goodbye.
See you guys.